Right now we are going to part 2 of part 2 of introduction to DC circuits. Part 2 introduction to DC circuits. Now here we'll discuss about factors. The first, resistance depends upon factors. Second one, inductance depends upon some factors. The capacitance also depends upon some factors. We'll discuss these topics today. First we go for resistance. On what factors does it depends and what are the formula. In the same way, we go for inductance. On what factor does inductance depends and what are the formulas we have. Next we go for the capacitance. We'll discuss about the factors and formulas. First one, resistance depends upon the material of which the conductor is made and geometrical shape of the conductor. It depends upon the shape and material. So what kind of material we are taking is very important for us. And second thing, resistance of a conductor is directly proportional to its length. Always it is directly proportional to length. This will be the equation 1. This will be the equation 1. Now third one, resistance of a conductor is inversely proportional to its area of cross section. A. Always this is called a second equation. This is called a second equation. And fourth one, resistance depends upon temperature of the conductor. Resistance depends upon the temperature of the conductor. From equation 1 and 2, we can make the equation called R is equal to rho into L by A. R is equal to rho into L by A, where rho is equal to specific resistance of the conductor, L is equal to length of the conductor, A is equal to area of the cross section, R is equal to resistance of the conductor. R is equal to resistance of the conductor. So these are the topic related to resistance depends upon factors. Resistance depends upon factors. And second one, inductance depends upon factors. On what factor does inductance depends? First one, inductance depends upon shape of the core. Shape of the core. Second one, it is directly proportional to the square of number of turns. And this is the equation 1. And this is the equation 1. See this one, this is the equation 1. Third one, it is inversely proportional to reluctance of the magnetic path. We call it as 1 by S. Inversely means 1 by S. See this equation 2. This is equation 2. From equation 1 and 2, from equation 1 and 2, L is equal to, we get the formula called L is equal to mu into n square A by L. See this S is called a reluctance formula. Since S is equal to reluctance formula, L by mu into A. Substituting this equation S, we get the standard formula for mu is equal to n square A by L, where mu is called permeability, L is called length of the coil, A is called area of the cross section, N is called number of turns. These are the formulas related to inductance. Mu is called permeability. Remember that mu is called a permeability. L is called length of the coil, area of the cross section area, number of turns. This is what about inductance. On what factor does it depends? Now come to third one, capacitance. Capacitance depends upon some factors. Capacitance depends upon some factors. The first one, capacitance depends upon the factors. First one, it depends upon the material. It depends upon the material. What kind of material are you taking? The capacitor will have in two plates. Already we have discussed. It is having a two plates and one dielectric medium. So it depends upon the material. It depends upon the material. And second one, it is directly proportional to the area of the plates. It is directly proportional to the area of the plates. See this equation. This is called the equation. This is called the equation. And third one, it is inversely proportional to the thickness of the dielectric. It is inversely proportional to the thickness of the dielectric. This is called equation 2. This is called equation 2. From equation 1 and 2. From equation 1 and 2. From equation 1 and 2. C is equal to A by D. C is equal to epsilon A by D. Where epsilon is called permittivity. A is called area of the plates. D is called thickness of the dielectric. D is called thickness of the dielectric. Where A is called area of the plates. Where epsilon is called permittivity. Permittivity. Now these are called totally we will discuss about the factors. Factors. You may ask me how to make a coil. How to make a coil. The coil is nothing but to take a copper wire, wound in the air, wound in the air, it becomes a coil. The core is called air. Otherwise, otherwise, take a steel bar, wound, wound a copper wire on the steel bar, then it becomes a coil. Then it becomes a coil. Then what about the capacitance? Capacitance consists of two plates and the distance between the two materials is the distance between the two materials is nothing but a dielectric medium is called air. Here air is called a dielectric medium. Here air is called a dielectric medium. So we can make a capacitance design. Capacitance design. Now these are the different kind of formulas. First formula R is equal to rho into L by A. Second formula L is equal to mu into n square A by L. Third formula C is equal to epsilon A by D. A by T. Clear? Right. Now we'll go for the now we'll go to the Ohm's law. My next topic is Ohm's law. Statement. What will be the statement? What will be the statement? Ohm's law states that at constant temperature, the current flowing through the material is directly proportional to voltage across the conducting material. Ohm's law states that at constant temperature, the current flowing through the material is directly proportional to voltage across the conducting material. Mathematically saying that I is directly proportional to V. I is equal to V by R. V is equal to IR. V is equal to IR. Where constant of proportionality R is called resistance of the material. Where constant of proportionality R is called resistance of the material. Is called resistance of the material. Remember that voltage current relation for resistor according to Ohm's law. This is the slope we get it. Linearly, it is called a linear. We have some limitations for Ohm's law. Very important one, limitations means we cannot apply. Ohm's law is not applicable to non-linear elements like diode and transistors. Diode and transistor. Ohm's law is not applicable for non-metallic conductors like silicon carbide. Okay. These are the different kind of applications. Limitations we called as a limitations. We called as a limitations. Clearly understood? Right. Now we'll shift to other topic called we'll shift to other topic called the basic analysis of a resistance. Basic analysis of a resistance. We'll shift to basic analysis of a resistance. Right? Now this is called a basic analysis of resistance, basic analysis of inductance, basic analysis of a capacitance. Now we'll complete in this part 2 the resistance, the resistor. In part 3 I'm going to discuss inductance and capacitance. Part 3 I'm going to discuss inductance and capacitance. Now I will complete resistance. We have four formulas related to resistance. Four from basic analysis, mathematical analysis. We call it as the mathematical analysis of a resistance. What is resistor first of all? It is the component which has the property of resistance. It is the component which has the property of resistance. It is nothing but a resistor. It is nothing but a resistor. You can see this one. You can see this one. Diagram. Now come to the formula. Current. When a current I amperes flows through a resistor of R ohms, when a current of I amperes flows through a resistor of R ohms, then the current is given by I is equal to V by R. I is equal to V by R amps. When a current I amperes flowing through a resistor of R ohms, then the current is given by I is equal to V by R amps. Second one, voltage. The voltage across the pure resistor is given by the voltage across the pure resistance is given by V is equal to IR. V is equal to IR. It is from Ohm's law. It is from Ohm's law. Now the power absorbed by the resistor is given by P is equal to VI watts, P is equal to I square R watts, P is equal to V square by R watts. Now come to the energy. Now come to the energy. The energy is taken by the resistor is given by E is equal to P into T, E is equal to VI into T, E is equal to I square R T, E is equal to V square by R into T. These are the different kind of formulas related to resistance. Related to resistance. The power absorbed by the resistor. See, these all studied in the formulas in basic terms of a electrical circuits. What are the basic terms? Current, voltage, power, energy. Power, energy. And this is what about basic analysis of a resistance. It is all mathematical formulas. It is nothing but a mathematical formulas. Clear? Right. Now we'll go for a next topic called basic analysis of inductors. And this also indicates the formulas. This also indicates the formulas. What is inductor? A wire of certain length and cross-sectional when twisted into coil becomes a basic inductor. Just take a copper wire, wound in the air, then becomes a coil. Wound in the air means it is twisted. It is twisted. Now inductor is the component which has the property of inductance. See, inductor should consider a property of inductance. Then it is called inductor. Then how to make a conductor? Then how to make inductor? Take a copper wire wound in the air, then it becomes a coil. Then what is the formula voltage across the coil? I need this formula voltage across the coil. So we have V is direct proportional di by dt, di by dt, di by dt. V is equal to L into di by dt volts. V is equal to L into di by dt volts. This is a standard formula. This is the standard formula. This is the standard formula. Okay, we'll continue in the part 3. We continue in the next part 3.